Let's explore the relationship between voltage, amperage, and power in electrical circuits. It's important to understand how these factors interact, especially when analyzing changes in electrical systems. We'll address a common misconception regarding the use of Ohm's law in scenarios where voltage changes. Consider a situation where the voltage to a business might be perceived as low. The question arises, if the amperage increases, will the electric bill be higher? It's crucial to understand that power companies bill based on kilowatt usage, which is a measure of real power. If the voltage decreases and the amperage increases proportionally, the kilowatt value might remain constant, resulting in no significant change in the electric bill. Let's analyze the formula the student used and why it's not applicable in this particular scenario. The student applied Ohm's law, which states that voltage equals current times resistance, or V equals IR. While Ohm's law is a fundamental principle in electrical circuits, it's essential to recognize its limitations. Ohm's law is valid for circuits with constant resistance. However, it cannot be directly used to calculate changes in amperage due to voltage fluctuations without knowing the resistance value and verifying that it remains constant. In the problem, the student attempted to calculate the resistance using the initial voltage and amperage values. They then used this calculated resistance to determine the new amperage when the voltage changed. This approach is flawed because it assumes that the resistance of the circuit remains constant despite the voltage change. Without knowing the actual resistance and whether it remains constant, Ohm's law cannot accurately predict the new amperage. The correct approach involves understanding the relationship between power, voltage, and amperage. The formula that applies here is that amperage equals power divided by voltage, or I equals P divided by V. In this case, the power is assumed to remain constant because the voltage and amperage changes are inversely proportional. Therefore, to calculate the new amperage, you divide the constant power by the new voltage. To emphasize, the student's error lies in applying Ohm's law without knowing the resistance and without confirming that the resistance remains constant. It's crucial to understand the limitations of Ohm's law and to use the appropriate formulas based on the known parameters. Explain to the student that Ohm's law cannot be used to calculate amperage changes due to voltage changes without knowing the resistance. Demonstrate the correct formula, which is I equals P divided by V, and illustrate how it's used to calculate the new amperage. When resistance information is unavailable or uncertain, it's best to rely on the power formulas, which relate power, voltage, and amperage. Let's address the second part of the question, which asks what happens to the amperage when the voltage on a circuit to a piece of equipment is raised. The answer is that the amperage decreases, assuming the power remains constant. This is because power is equal to voltage times amperage, or P equals V times I. If the power remains constant, an increase in voltage must result in a corresponding decrease in amperage to maintain the equality. Think of it like this: if you have a fixed amount of power to deliver, increasing the voltage is like widening the pipe, allowing the same amount of power to flow with less current. To summarize, firstly, Ohm's law is not always applicable for calculating amperage changes due to voltage changes, especially when resistance is unknown or not constant. Secondly, the correct formula for calculating amperage when power is constant is I equals P divided by V. Thirdly, when voltage increases on a circuit with constant power, the amperage decreases. It's essential to understand these relationships to accurately analyze and troubleshoot electrical circuits. Remember that electrical calculations involve applying the correct formulas based on the known parameters and understanding the underlying principles. In the absence of complete information, such as resistance values, it's best to rely on the power formulas, which relate power, voltage, and amperage. These formulas provide a more accurate representation of the relationships between these factors and allow for more reliable calculations. When working with electrical circuits, always prioritize safety and follow established procedures. If you are unsure about any aspect of electrical work, consult with a qualified electrician. It's important to have a solid understanding of electrical principles and to apply them correctly to ensure the safety and reliability of electrical systems. This includes understanding when to use Ohm's law and when to rely on other formulas that better represent the relationships between voltage, amperage, and power. Keep in mind that electrical systems can be complex and require careful analysis. By understanding the fundamental principles and applying the appropriate formulas, you can accurately assess and troubleshoot electrical circuits. Electrical calculations are essential for various applications, including designing electrical systems, troubleshooting problems, and ensuring the safe and efficient operation of electrical equipment. A thorough understanding of electrical principles is crucial for anyone working with electricity, whether you're an electrician, engineer, or technician. By mastering these concepts, you can confidently tackle electrical challenges and contribute to the safe and reliable operation of electrical systems. Remember to always prioritize safety and follow established procedures when working with electricity. If you're unsure about any aspect of electrical work, consult with a qualified electrician.